Okay, if I give you something like this, we're just talking through a Venn diagram. I know it's not on there. It's okay. It's two circles. And say I tell you that there are 50 people being surveyed for this Venn diagram, okay? We're just going to talk through this. If I say to you that we're comparing the people who like pizza to the people who like carrots, okay? And I tell you that 7 people like carrots only. If I say 7 people like carrots only, do I have to wait, fill in the middle, and then be able to answer the question or fill in the actual Venn diagram when it says only? No. Remember when it doesn't say only, so if it just said 7 people like carrots, then I would actually need to know the number of people who like pizza and carrots to subtract it off, correct? But if I say 7 people like carrots only, I can immediately go to here, right? We agree? Okay, what if I say now that 30 people liked pizza? Can I go put that in? What do I have to find out first? You'd say, Mrs. Lepp, how many people liked pizza and carrots? Because I'm not allowed to fill in pizza until I know how many like pizza and carrots, right? So if I tell you 5 people like pizza and carrots, you could fill that in. Then what would you do? 30 minus 5, because it's not pizza only, it's pizza, and that's the whole circle. 30 minus 5 leaves me with 25. How would I find the outside people? Yeah, so it'd be 50 minus 37, which is 23. That's a lot. It's 13. Oh, it's a really large. Because 3 to 40 and then 10. So 13. Right? And we fill it in that way. So if the word only comes up, do I have to subtract? Do I have to subtract if the word only comes up? No. If it says carrots but not pizza, do I have to subtract? Carrots but not pizza is carrots only, right? It's just a fancy way of saying that. So I don't have to subtract. Okay? So, back to here. This one here says the diagram displays the number of students and members of student council or the yearbook. How many students are on student council? How many? 15, because I have to look at the whole student council circle, right? Not just student council only. On both student council and yearbook, how many? 3. On the yearbook committee, but not on student council, how many? Yep, because it just means yearbook only, right? And then on student council or yearbook, what shape is that? The snowman. So the whole snowman, right? The 12, the 3, and the 7. So that's 22. Now the next one here says, in a homeroom of 20 students, 15 take math, 12 take social, 10 take math and social. So I'm going to do the math and social first, right? So it said that 10 take math and social, so that goes in the middle. Then it says 12 take social. So how many take social only? 2. You subtract. And then it says 15 take math. Does it say 15 take math only? Or math? Math, so it's the whole circle. So how many take math only? How do I find the outside? Subtract 3 numbers from 20, because those are the people who take everything, or take either. So that's 17, so it would be 3. Now, do I just draw a Venn diagram and say, Mrs. Lepp, you can figure out the answer. You're smart. No, we do not do that. Mrs. Lepp will figure out the answer, but she will not give you the mark for it. How many students take neither math nor social? You'll say 3 students take neither math nor social. Here it says in a survey of 400 households, 208, so this is the total. 285 had a PDR, 320 had an MFP, and 63 had didn't have either. So I gave you both singles and the neither. So you need to know this, that when I give you both singles and the neither, you can add those up and subtract it from the total and you'll get the and. You can either do it that way, or like I did the other day, you can do 400 minus 63 and then take the other two, add it up, and see how much is left there. But if you're given like the PVRs and the MFPs and the neither, you can just add them up. So we can go 285 plus 320 plus 63. Because that's people putting in a ticket. They put in a ticket if they're in neither. They put in a ticket if they're PVR. They put in a ticket if it's an MFP. So we have an 8, 16, 6. So we have 668 tickets were put in, right? You know, people can put in 2, right? We talked about that. They can put in a ticket for PVR and an MFP if they own both. So that's 668. The problem is there's only 400 households. So how many are in both? How many are in both? I know you know the answer. How many are in the middle? Yeah. 268. And the reason why there's 268 is that is 268 more than 400 people that could be in those circles, right? The box can only contain 400 people. So if I add them all up and I take off the 268, or take off the 400 to get 268. So then the PDR has to hold 285. What's 285 minus 268? And then the MFP should have 320, but there's 268 already in there, so how much? And then on the outside, 63. Now I told you yesterday that what you could do is just take 400 minus 63, then you're left with 227, and then add the other 2 up, right? Subtract 227. Still gets you the middle. I don't care which route you go as long as you get the 268 in the middle. So here it says, write an expression for the number of households who have an MFP and a PVR. And how many are there? 268. Then write an expression for the amount of households that have PVR and not a MFP. So that's a PVR only. So that would be 17. And then write an expression who have an MFP but not a PVR. So that's an MFP only, so it's 52. We're going to do the rest of them tomorrow, but I want you to go down to 7 because we're going to talk about 3 circles today. We're looking at 7 right now. So 3-circle Venn diagrams have a lot more information, correct? As opposed to a 2-circle. 2-circle Venn diagrams have 4 pieces of information to fill out. 3-circle Venn diagrams have 8 pieces of information. So when we looked at a 2-circle, when I say you have 4 pieces, you have 1, 2, 3, and the outside 4, right? Whereas a 3-circle has 1 in the middle, 2, 3, 4, 5, 6, 7, 8, right? 8 pieces have to be filled in. So you know you're done a 2-circle Venn diagram when 4 pieces are filled in. You know you're done in 3-circle when your 8 pieces are filled in. And remember, we have to work from inside out. So we have to work from the all 3s to the ands of all to the 2s, so the eyeballs, to the singles, to the ors. So with 3 circles, we always work from the all 3 first. We can do the onlys. We can always do the onlys first, right? Onlys can always get put in whenever. If it's only cycling, you could fill that in right away. So we do all 3, then the ands, and the singles, then the ors. That's how we always have to fill it in. Because we're going from smaller pieces to bigger pieces. The all 3 is that little triquetra symbol in the middle. The ands are still the eyeballs. The singles is just the circle. And the ors are the snowmen. We do deal with them last. So, here it says Shannon's High School starts a campaign to encourage students to use green transportation for traveling to and from school. At the end of the first semester, Shannon's class surveys 750 students. So no matter what, my Venn diagram needs to have 750 people in it, right? So I'm going to draw myself a little Venn diagram. And I'm going to put this out here to help myself. I know that inside there I need to have 750. In the school to see if a campaign is working, they obtain these results. 370 use public transit, so that's a single. 100 students used cycled and public transit, so that's an eyeball. 80 students walked in public transit, so an eyeball. 35 walked and cycled, so an eyeball. 20 students walked, cycled, and used public transportation, so it's like the little triquetra inside. 45 students cycled or used public transit, that's an or, it's a snowman. It's the very last one I'm going to touch, right? And 265 students walked or cycled, again, snowman, very last one I'm going to touch. So we have to start from the inside out because we have to subtract as we work our way out. So what are our options? We have public transit, cycling, and walking. So I'm going to do public transit. Cycle. Walk. Okay. So where did I say we have to start? In the very, very middle, in the all three. Did they give it to us?
Yes.
Yes. How many are there? 20. So check mark 20. Then we have to go to the ands, the eyeballs, correct? So we have a few of them. We have 100 students cycled and used public transit. So cycled, did they say cycled and used public transit only? If they said only, I would put 100 here, correct? But it doesn't say that. It says cycled and used public transit. So I know in the cycled and public transit eyeball, I need to have 100. How many do I currently have? So how many are public transit and cycled only? 80. So do you see why we have to start in that middle section? Because we're going to have to subtract as we go along. Because yes, these people also walk. These 20 people walk as well. But they do public transit and cycle. So they're part of that 100. Then we have 80 students walk and use public transit. So 80 students should be in this little eyeball. 80 students walk and use public transit. How many are already in it? So how many are walking public transit only? 60, exactly. Then we have 35 students walk and cycle. So in the walk and cycle eyeball, I need to have 35. I already have 20. So how many just walk and cycle only? 15. Now I have the options of public transit by itself or an or and an or. What do I have to do next? I do alls, ands, then the singles, correct? I'm going from smallest shape to biggest shape. This is the smallest shape through all three. Then the eyeballs are the next smallest shape. Then the circles are the next smallest shape. Then two circles together is the biggest, right? So I have to go to the single. 370 students use public transit. Did it say public transit only? No, so it's the public transit circle. There needs to be 370 in this. How many are already there? 160. So how many public transit only? 210. Now some people want to use the cycle or walk snowman next because cycle or walk has 265. What's the problem with the cycle or walk snowman? Right. So the cycle or walk snowman, my biggest problem is I'm missing two pieces. Right? And I have to subtract everything else off. So some people will subtract it off and then try and divide it by 2. Can we assume that those are the same? No. So we can't do this one right now. We have to wait. Let's try this one then maybe. This one is 445 students cycled or used public transit. So we look at the cycle or public transit snowman. Cycle or public transit snowman. Can we do this one? Mm-hmm. Yes, there's only one piece of information missing, right? It's just this piece here. So we're going to take 445 and subtract 385. And what do we get? Type in your calculators if you don't know. Because this is 370, 385. So what's 445 minus 385? Now can I do the green one? Now can I do the Walker cycle? Yes, I have enough information now. So now I can do the Walker cycle, snowman. So I need to have 265 in here. I currently have 100, 220, 235. So what's in walking? 30. Now am I done? I have 1, 2, 3, 4, 5, 6, 7 pieces of information filled in. What do 3 circle Venn diagrams need filled in? 8. So I'm missing the outside. So I know that this should be 750, right? So I know that this here is 445, so this is 475. So what's on the outside? 275. So it said, how many students use green transportation for traveling to and from school? When we count up all those circles, those are all the green transportations, right? And they were 475, right? Okay, we're going to bring this out for tomorrow to finish off the other ones, but in the meantime, I want you to go back to your notes, please. 3 circle Venn diagram notes. We're here. Okay. So yesterday we got to here and we filled in the sets, but we didn't fill in the Venn diagram, right? So what was there a number that we discussed this part? We said, was there a number that fit into all 3? And you guys said no. So I said, okay, we're going to leave that blank, right? And then the bell rang. So let's go to just multiples of 8 then. Are there any? We have to do the eyeball. So there's nothing in here, right? There's no numbers in here, so I leave it blank. I don't put a number. If I put a 0, I'm saying 0 is there, right? So I don't want to put anything in that one. Are there any overlaps between E and F? Are there any numbers that overlap between E and F? Which ones?
8, 16, 24, 32,
8, 16, 24, 32, and 40 are overlaps between E and F. But they don't overlap with S, so that's why they're only in that one spot, right? Then we have to look at F and S. Are there any numbers between F and S that overlap? Are there any numbers between F and S? Nope. So this little piece here in F and S, the whole eyeball, is going to stay empty. Are there any numbers between E and S? No. So then we go to E, E only, and we list the ones that are in E only but not in the other two. So actually all of E is in there, right? Then we go to F, 4 isn't in here, 8 is, 16 is, 20 isn't, 24 is, 28 isn't, 32, 36 isn't. And then all of S is standalone, so it's by itself up here. 1, 2, 17, 34. Are we done? Yeah.
About the 12 and
12 in F. I did. Totally. Even here too. Is there anything else that we're missing? Yeah, all the numbers in the universal set that are not in there. So the numbers from 1 to 40 that don't appear in there. So 1 and 2 is here, 3, 4 is in there, 5, 6, 7, 8 is, 9, 10, 11, 12 is, 13, 14, 15, 16 is, 17 is, 18, 19, 20 is, 21, 22, 23. 24 is, 25, 26, 27, 28 is, 29, 30, 31, 32 is, 33, 34 is, 35, 36 is, 37, 38 is, 39. Why am I putting the dots behind the numbers again? Yeah.
Those are the actual numbers, not like amounts of numbers.
Exactly, shows that they're actual numbers, not amounted numbers. Yeah. We don't have to describe the different ways of writing sets. Did we get that? Then we're going to flip over. Why, I gotta get your notes up, friend. So we have to answer these questions. Oh gosh, where'd I go? It's a debacle. This is terrible. I have to flip between two. So they want what's in E and, you can just tell me what the things are. So E and F. What's in E and in F? Well, we'd list 8, 16, 24, 32, 40. It's on the next page. And then we have, they want to know, is E a subset of F? Is E a subset of F? Is everything in E in F? Yeah, you can even see it. So E is a subset of F. That is true. The next one says, is F a subset of E? Is F a subset of E? Is everything in F in E? No. And then we have E a subset of E. Is E a subset of E? Is everything in E in E? Yeah, every set is a subset of itself. That's over here. We won't worry about that because it's hard to write it. Let's look here. I gave you information. I gave you a 3-circle Venn diagram. What do you suppose I'm going to want you to do? Don't all answer at once. Fill it in. I'm going to label them so we all kind of go with the same thing. So I'm going to label this one a cell phone. And then I'm going to label this one texting. And social networking. Try and fill it in.